Okay. Good morning, Lorenzo, and as you can see, I'm one of many. And I have the honor and the pleasure to present to you the Concurrent Calculi Formalisation benchmark. We start from a very simple aim, We want everyone to mechanize session types. So first we wanted to mechanize session types ourselves, and multi-party session types. Then we think this has value, and we want the whole community to engage in this. Let's say we want more and more paper to be accompanied by mechanized proofs. And when I say mechanized, I mean, you saw an example, just in an example, right? Marco presented something that was mechanized in Coq. So I'm talking about this kind of softwares, proof assistants, like Coq, Isabel, Agda, Abella. There's many, and this was not a complete list. Anyway, so we focus on this work. We wanted to do mechanized session types using these kind of softwares, and we this is the main motivation, right? We like them. We kind of did also. Many of actually all the authors, all the participants in this project did mechanize something. And we think that this thing is, the mechanization for research paper is fun and useful. First of all, when you mechanize computer science method theory, programming language method theory, you can get out of the mechanized proofs and definitions certified code into a target programming language, mainstream programming language, because you could consider the proof assistant a programming language itself. Then also mechanized proofs help you avoid mistakes in overlooked cases. Marco had some examples of make life easier. Papers can miss a rule, or they don't show the proof in so much detail, and some case of induction is just by induction hypothesis, and then it's not. So a proof assistant will not, in your interaction with it, will not accept it. And to be fair, this is it's been my slogan for a while. I'm not saying that proof assistants are better than pen on paper proofs. They are more. So it's not better knowledge that we seek more knowledge. We seek to understand more about our theories, our developments and research. Okay, so we are excited about this. We have our experience in mechanizing session types, but it's tough. It's hard work. And therefore, we decided to take a step back. And to start talking to each other and to the community as a whole in the spirit of the POPLMark Challenge. Probably you know about the POPLMark Challenge. It's a very influential community project and paper from the early 2000s, where, again, many very, very smart people, very, very good researchers came together in the community of programming languages and had this document presenting some mechanization challenge, some benchmarks, detailed, to the programming languages community. So they highlighted these challenges were based on a system that highlighted some fundamental features of programming languages. And they wanted to do what we want to do, but in a different context. So these projects, these benchmarks, want to encourage discussion in the community. They want a discussion, comparison of different approaches and of different programming language. Yes, maybe, but also of different proof assistants. And through the development of guidelines, tutorials, more support, more often than not, proof assistants don't offer the user enough support. And all of this for reusability. And in our case, all these things in our benchmark will focus on session types and concurrency. As I said, we took a step back from all the hard work of mechanizing our theory of multi-party session types. We took a step back and we tried and identify as challenges, as fundamental challenges, some topics that we would encounter over and over again in our mechanization and when developing our theories for our papers. And these topics are from the literature. They will not look new to you, hopefully, And we have identified these 3 ones in particular, and we have developed our challenges according to this division, these 3 topics. One is linearity and behavioral type systems, so the actual session types or behavioral types. Then we have 2 challenges that only deal with processes, so we rule out the types for now because we wanted simple challenges. We wanted to isolate the problems. Second one is deals with name passing and scope extrusion. Also, this should be well known. And finally, coinduction and infinite processes. Again, my work is very easy now because both talks before mine mentioned coinduction. That's our small website. It's work in progress, but please have a look. You can find the technical report with the details of the challenges and also how to join and start discussing these things with us in case you're interested, and I hope so. So let's start. I'll just present the challenges, right? The first challenge concerns linearity and behavioral type systems. So we give, first of all, a simple language, a simple process language with values. Now, A is a value, L is a variable for values. Then we have a terminated process, the 0, and a send construct and a receive construct. You can see that the send construct sends a value, while the receive needs to receive via X, so via an endpoint X, over a variable L. And that variable is bound. Very, very interesting for mechanizations. Not really, but tedious. Then we have parallel composition, as usual in concurrency. And finally, restrictions of 2 endpoints. So here we use 2 names for the send and the receive. We restrict the 2 endpoints, the send and the receive endpoints of a channel. Okay, these are processes. Again, nothing should be surprising, and not even in the semantics. As you can see, the main rule is the first one there that explains how a message can be sent and received, how communications happen. And under a restriction, so after we declare the 2 endpoints, X and Y, a process can send via X, A, the first one, the one on the left, to the one on the right, will receive over Y on the variable L. And then the step can be performed. Again, as you can see, after the reduction is performed, the step is performed, the process there, for the right-hand side, the process who receives, continues as Q, the syntactic continuation, with a substitution. Again, so much fun mechanizing substitution. So then we have other 3 rules in our semantics, which are just to make sure that the semantics is compatible with the language. But the last one, which factors in structural congruence, I will not go into detail. It's a pretty standard. Any, I don't know, process calculus paper will offer some. It's in our technical report. So you'll find it there, but no surprises. Now we want to type. We want to type the processes to achieve these 2 things. And we give to the aim a type system. And we have our session types, let's say, which are very simple. End for the terminated process, base for our values, and then a send and a receive type. Actually, a receive and a send type, and that's it. We have context for value variables and for endpoints. And that's our typing system, our type system, our typing rules. Again, very much standard. The important thing is that, in particular, the second rule, TPAR, is the one that allows us, that enforces the first point. So no endpoint is used simultaneously by parallel processes. This is enforced by the splitting of context with the rule to TPAR. The second thing is the 2 endpoints of the same type of session have dual types. Again, duality, here I mention it. I don't introduce formally, pretty standard. Please look at the technical report on the website. However, 2 endpoints of the same session have dual types, namely one sends and the other receive. And this is enforced by the restriction typing rule, okay? So nothing surprising. And here comes the challenge. So we asked the mechanizer to display their techniques and their proof assistants when proving subject reduction. You should be familiar with this. Typing is preserved by reduction. second part of the challenge, well, you can also prove type safety. For type safety here, a well-typed process is well-formed. We'd have to introduce a well-formed predicate, details in the technical report. But basically, what we are enforcing here is that no two endpoints are both a send construct or a receive construct. So again, it's a duality, this time defined not on the types, but directly on the processes as well-formedness.
Are you sure this is the subject reduction you want to prove?
I am sure.
Okay.
I am sure.
I don't think it works. But
it does. There is, if I don't
change, right?
Sorry?
The delta should change.
No, they don't. There are two approaches. I was surprised at first as well, because I'm not, now I am, but I wasn't when I started the session type person. But you can have the subject reduction with the types staying the same. People here can explain better than I do. It's in the technical report. And there's also a note about this question. Now, I don't remember myself.
Or maybe it's because the way you set up the reduction proof.
Yeah, it's the typing and the reduction, yes. So you always be able, I think, if I can try and give the intuition, but I might be wrong, so my co-authors, please correct me.
Yeah, you don't waste your time on it.
No, it's just, I think it is because the type of, typing okay, but it's because the send and the receives happen under a bound.
Yeah, so it's under the... Yeah.
No, but also the original paper it's the same, because when you have two dual sides, they cancel them out and they become like a bottom in the original binary session types. So you have the same result.
Yeah.
So they're gone.
I have the same question about the second year.
The what? Sorry?
Yeah, also the same result.
I couldn't hear. This is supposed to be. It's good, it's good. So this was supposed to be basic, right? Like traditional session types. You should have known. Sorry, you were asking something.
I have the same question about the second year. Don't you want a stronger result there than the fact that...
About that, you can, of course, have stronger results. This is on purpose simple. So this, nothing new in these challenges. This is identifying some fundamental and well-known aspects of the theory of session types and concurrency to be mechanized. Then, hopefully, many people can mechanize them. This is supposed to be something that people can do. But in the process, they will display the feature of their proof of system, their great idea of techniques of how to formalize. They will develop a tutorial. So yes, probably you want something stronger if you really have to develop your own system that works. But here it's just isolating the bare minimum. And you'll see also in the next two challenges. Let me go quickly through them. So the next one is about name passing as scope extrusion. So processes. We give a slightly different calculus, again, with this idea of isolating things, of isolating the feature that we want to mechanize. And here is the same constructs, but if you can see a send and receive, well, restriction sends only one name, but it's a choice, not really a difference. The real difference here is that we send and receive names. And actually, we don't have values, because we wanted to isolate this simple behavior. It doesn't have to be meaningful, it has to correctly capture and isolate the behavior for formalization, with the purpose of being able to mechanize it. Here I show you this challenge through a relevant example. So this is a process where, this is a process that has two processes in parallel. The one on the left introduces via restriction a variable y and sends it. It wants to be able to send to the process on the right that will receive it on x on the variable z, but at the beginning, when the process looks like this, the scope of the new binding is only the left-hand side. So this scope needs to be extended. Again, standard concepts. From the literature, we found two approaches. We can represent formally this idea of extending the scope, and one is through a combination of structural congruence and the semantics defined as reduction. So first, if sorry for the mismatch. So we have to check in our example that the y is, the bound variable y is not in the free names on the process on the right. So a bit of substitution of renaming needs to happen there with respect to the rule. But anyway, once we check that that variable is not on the free names on the right and of the process on the right, we can say that these two processes are structurally congruent, and then we can perform a reduction step simply with a rule. I will not present all the semantics really, I'm just mentioning that there is a rule for communication from send and receive, and a rule for that lets the reduction happen under restriction. Okay, this is fairly simple. Then there's the alternative approach, which is instead of structural congruence and reduction, we use a label transition system to define the semantic. We want to prove this, then, which is the same, we have the same process and the same resulting process on the right, so the same starting process and the same resulting process, but instead of having one step of structural congruence and one semantic step, we have one single transition, label transition, with a silent transition tau. And there's how we prove this. We start from, we go bottom-up reasoning. So we prove the red thing, and we have a rule for that, which is a closed rule that allow us to capture both branches of the parallel under the restriction, even this pretty standard. But then to have this, we have to prove the two things in red, which is an output and an input. In particular, we see that the output on the left-hand side, it's a bound output, so we have to open it. Again, here, to make things sound, we have to distinguish the actions between free send action, the one on the top, and a bound send action on bottom. It doesn't, I'm not going into detail here, it's in the technical report. Again, the important thing is, when mechanizing, we have to take care formally of these things, very carefully, otherwise the proof assistant will not accept. So to make things sound, we chose this approach. And then finally, we just finish our proof with a simple output and a simple input rule. Last, okay, first the challenge. So I presented you the two approaches. The challenges says, okay, please, ask the mechanizer, please prove that the two approaches to model scope extrusion and impulsing are equivalent. These are the theorems. I'll go quickly to the next one. Anyway, also these things, they are all from the literature. They shouldn't be new. They are sometimes new to me because I didn't study all of it, but they're not anymore. Then, coinduction and infinite processes. This is the last challenge, sorry. This is the last challenge, and it deals with coinduction. Very similar syntax as before, values, variable. The only thing is the only new thing is the thing in green, which is replication, which actually introduces infinite behavior in our processes with this rule. Now, the semantics, again, I will not give it all. Check the technical report. Is given as a label transition system. And this is the rule that introduces infinite behavior. As you can see, the process P, if the process P step, the process exclamation mark P is allowed to step to a process that adds in parallel, replicates itself with a parallel construct. And this step can be clearly done an infinite amount of time. So how do we deal with infinite behavior? With coinduction, and in particular, we start saying how can we relate to process with infinite behavior? How can we reason about the behavior of processes? Well, by what we can observe externally. And what we can observe externally in a communication setting is only what's sent and what's received. So we introduce a predicate formally that tells us if a process can perform a send or a receive action, as usual. And this is all we can observe. This, again, very, very standard. Then we define a strong bar bisimilarity. And here is coinduction. You see the word largest, the larger symmetric relation such that, and we have to condition P, whenever P is related to Q, we have that what's observable for P is observable for Q. And then if one of the processes steps, then also the other steps to something equivalent. Okay, this is an equivalence, strong bar dissimilarity, but not a congruence with respect to context. Here you have a small example. So what do? For this challenge, we introduce strong bar congruence. So we define this congruence that way. So basically we enforce we say that two things are related if, by congruence, if they are bisimilar for when substituted in every context. And of course, once we define, we have to prove that there's an equivalence relation and a congruence, and it's included in strong bar bisimilarity, very standard. And finally, we have the main result that we ask the mechanizer to prove as a challenge, which is the theorem that characterizes strong bar congruence via substitution and parallel composition. I'm done with the challenges. So we ask the mechanizer to take these challenges and to complete them via mechanizing the definitions and the proof of the theorems of the result I have presented to you. I have a question for you. Was this tedious? Because the answer is kind of positive. It is. In particular, it's tedious when you have to repeat the mechanization effort for each one of these concepts every time you want to mechanize a new system. You have your own novelty. You have your own new idea on a system of session types. You love it. You want a mechanized proof. You know you can do it. And then you start, oh, okay, I have to prove subject reduction, or I have to take care of scope extrusion. So for this reason, for the tediousness of that is intrinsic in a mechanization effort, sometimes it's fun, sometimes it's tedious, we want a community effort. We are asking for a community effort that will develop, ideally, and we will be very happy in case, we'll develop tutorial formalization for different approaches and different proof of system. Comparing the proof of system. So, you know, Coq can do dependent types. Isabel has classical reasoning, these kind of things. We want to have this comparison, maybe in a better way, a more friendly way than the usual, but focused on session types and concurrency. Hopefully, this will establish best practices so that you know that if your system that you want to mechanize has needs coinduction, you know where to go for, what proof of system to pick, and fine, perfect. I'm closing, and how to do that. The first 3 points are the benefit for us, for the community of session types. The last 2 are the benefit for proof of system community. They can investigate the strengths and weaknesses of their proof of system and improving on those. Why contribute and how to get involved? Now, if you are interested in this, talk to us. We have a mailing list, that one. We have a website for you to check the technical report, engage, try and mechanize something, play with that. And again, the why is what I tried and highlighted throughout the talk, is the relevance and interest for our community, our problems, and other people's, the proof of system community, connecting this to the community, conducting your own mechanization. That should be, at least for me, it's fun when I manage to do it. But also it leads to publication, both of the novel system, that you really like, your novel system, what I called before your novel system, and also you can publish both experience reports and tutorials, and this again will benefit the community. Also, it has a pedagogical value because you can always start with your PhD student or with your colleague that wants to get into proof of system with one of these challenges, which is self-contained, pretty small, a good starting point. To conclude, this was, for the POPLMark challenge, the quote, how close are we to a world where every paper on programming language is accompanied by an electronic appendix with machine-checked proofs. Blah, blah. We only have substituted that. Very simple. Very, very simple. I'm done. Thank you.
Thank you very much. We have fun. Yes.
Yes.
I think I have a very high level, maybe a good nasty question, which is, if you take like now one submission that you prepare and without mechanization, and you then want to submit with a mechanization, what do you think is the overall like head of work, and how would that slow down the pace of publications and submissions?
From a it depends. Are your co-authors good mechanizers?
Just to give
Because
you a
in
background,
case,
like the very first paper I authored was actually pretty much this for a different domain, and it takes quite some time for people to pick this up. But then, in the meantime, you have like two sub-communities, one using mechanization and one that does not. One has like this higher output of publications, and the other does not. And this is kind of the currency of our market, right?
So,
That's
yeah.
kind of one of like, what do you think? Like, what's the overhead? That was the actual question.
The overhead, in my experience, can be months, can be almost nothing. It's true. It's true. Depends really on how you engage in that, right? It depends. If you add, I don't know. We're doing economics now, but if you add one co-author who's a good mechanizer, while you work on the theory, they can mechanize or this thing. I don't know. It usually has some overhead. That's exactly however the point of this, right? Because if you establish best practices, why am I? I wanted this, where you can see the website. Sorry. When you establish best practices, that would be the aim. Of course, it's not simple, but that's what we do, no? We do new things, we do research, we engage in things. We try.
There was the question over there. Yeah, you.
Okay, so thank you for the talk. Most of the times we need to combine features, right?
Yep.
For instance, I'm working with a level transition systems in a linear pi calculus. So what you're proposing works very well because you're working in isolation. But the combination has impact.
Of course.
It's not just summing, right?
Of course.
So what I suggest is that what would be the simplest combination that makes an interesting and an interesting challenge?
So the challenges were thought exactly to isolate these things because we are aware of that. We hope that as when the solutions come and we plan to publish them on the website, maybe someone engages in this kind of combination. And we will again go through the whole process of finding support, some tutorials, some best practice. This is the whole idea of the process. We started very little because we know that already this requires some effort. Of course, when you combine two, it's not the sum. But that's why we started the process, the project, sorry. Then, of course, you might want more things. There's nothing about multi-party, for example. So the whole projection, and Marco presented, the merge problems, the coinduction there, sorry, it's not here yet, but we had to start somewhere. Sorry.
Okay, very, very fast. Marco.
I just had a comment, maybe with respect to what Felix said. I mean, after the first POPLMark, hasn't the number of mechanized papers increased over the years?
Yes, it does. At least that's the claim in many places. Yeah. That's the claim, at least. I haven't seen the number now, but that's the claim and what they report. So it's dragging attention on this.
Simon suggested I bring that up in the panel so we can discuss
Yes.
later.
Last question.
Yeah, so I have a philosophical question. So if you look at the three challenges, then 2 or 3 are classic process calculi issues, right? So,
hopefully.
And then the challenge I understood was about session type. So if you think about session type being more going beyond process calculi, going beyond the pi calculus. So what is you're actually to engaging to people to beyond process calculation. Because at some point, I think that one of the impacts of sources of impact of session types is that it can go beyond the pi calculus, right? So you need to learn pi in order just to do session types.
Okay, can I answer?
That's
Do you have time? Fast.
In my impression, I thought that all these things about the pi calculus and the equivalence of the pi calculus had been already addressed in Isabel by Joachim Parro and students, but that was my impression, or like, I thought that they had already solved them.
Yeah. This is not new work. First of all, this is not new work. We wanted to start it from something, and we wanted a unifying container, not even to have all the same formalization to be normative, but to contain everything. And we wanted to start from session types, but since it was very hard, we tried to isolate some features that you will encounter no matter the system. I understand that if you only do session types, you might not want the calculus, so you might not even care about the relation, but usually types are for typing.
If you have some concurrent calculus, you don't need to care about name passing or extrusion in the explicit sense that you're doing it here. That's my
We started somewhere. That's my short answer. Sorry, Kristen.
So
We can discuss more later, of course.
Exactly. Let's thank you for speaking again, and we have coffee.